Instrumentation used in atomic absorption spectroscopy. The basic components of an atomic absorption spectrometer are shown in the figure. The difference between atomic absorption spectrometer and that of a spectrophotometer, which is used in solution measurement, lies only in the radiating source and the sample container. The different parts of atomic absorption spectrometer instrument are as follows. The first is the radiation source. A hollow cathode is used as the radiation source in atomic absorption spectroscopy, which is shown in the figure 2. A high voltage between 300 to 500 volts is put across the anode and cathode. Atoms of the gas argon or helium are ionized at the anode and they are attracted towards cathode. The fast moving ions strike the surface of the cathode and physically displace the surface metal atoms into the atmosphere. The displaced atoms are excited and they emit the characteristic spectrum of the metal used as cathode. Hollow metal cylinder acts as a cathode and is up to 10 to 20 millimeters in diameter. The enclosure is made up of thick walled glass having a transparent window fixed to one end. The design of the cathode is cylindrical in nature, which tends to concentrate the radiation in a limited region of the tube. Neon or helium gas is filled in the hollow cathode lamp, and its function is that it is responsible for excitation of the ground state metal atoms. It dislodges atoms from the surface of the cathode, and it is the main source of current. The pressure in the hollow cathode lamp is maintained at a value between 1 to 5 torr. Gaseous discharge lamps or arc lamps are also used as radiation source. They produce a line spectrum as a consequence of a passage of electric current through the vapor of metal atoms. These sources are particularly useful in producing alkali metal spectra, the common example of which are sodium and mercury vapor lamps. The second main part of atomic absorption spectrometer is the atomization unit. Atomization can be carried out in one of the following manners. Ovens. Ovens are those in which sample is rapidly brought to a high temperature. Electric arcs. In these, the solid or liquid samples are put to high current or to a high potential. Sputtering devices. In this, the sample held on a cathode is bombarded by the positive ions of a gas. Flame ion atomization. In this, the sample is sprayed into a gas flame. Then this method has proven to be the best method. The next are the oxidizing agents and fuels. Natural gas, propane, butane, hydrogen and acetylene are the common fuels which are used for flame production. Air which is enriched with oxygen and nitrogen are the common oxidants. Low temperature flame is advantageously used for elements which are easily converted to the atomic state, such as cadmium, copper, lead, zinc, etc. Alkaline earth metals, because of their tendency to form refractory oxides, require higher temperature for decomposition. Rare earths like aluminium and beryllium form very stable oxides and require still higher temperatures, which are provided by oxygen acetylene or nitrous oxide acetylene flame. The ratio of fuel to oxidizing agent also affects the extent of atom formation in a flame. The next part which is used or which is present in the instrument is the chopper. Chopper is a rotating wheel which is placed between the hollow cathode lamp and the flame. Radiation from the hollow cathode lamp is not supposed to be continuous. Otherwise, it will not be possible to distinguish it from other radiation which are transmitted from the lamp. Burners are the next component of the instrument. Total consumption burner and the pre-mixed burner are used in atomic absorption spectrometer. In the pre-mix burner, the sample is aspirated into a large chamber by a stream of oxidant, where fine mist of sample, the oxidant and fuel supply are mixed and then forced to burner openings. Large droplets are accumulated in the bottom of the chamber from where these are drained off. In a total consumption burner, the sample solution, the fuel and the oxidizing gases enter through separate passages and meet at an opening at the base of the flame. As the sample containing metallic element to be estimated is a liquid, the flame breaks up the liquid sample into droplets which are then evaporated, leaving the residue which is reduced to atoms. Next component of the instrument are the monochromators and filters. Prisms and gratings are the most commonly used monochromators. The requirement of this analysis is a narrow bandwidth to isolate the line to be measured from other lines. Now, this might reduce sensitivity. Common monochromator is of 1 by 2m focal length with a linear reciprocal dispersion in the range 16 to 35 angstrom per millimeter. The function of a monochromator is to select a given absorbing line from spectral lines emitted from the hollow cathodes. Next components are the detectors. Photomultiplier tubes are the most commonly used detectors. Dark lines are obtained on film whose intensities are compared. This comparison leads to accuracy but is difficult with poor precision. Photomultiplier tube converts the radiant energy into an electrical signal. Both null point and direct reading meters are used, which are calibrated in terms of absorbance or transmittance. Next part of the instrument is amplifier. The electric current from the photomultiplier detector is fed to the amplifier, which amplifies the electric current several times. Lock-in amplifiers are preferred, one of which is shown in the figure. This lock-in amplifier provides a narrow frequency band pass and helps to achieve an excellent signal to noise. Signal from the photomultiplier is fed to an AC amplifier to modulate the energy source. The modulated signal enters the synchronous detector. Also, a signal from the reference source is modulated at exactly the same frequency as the signal from the photomultiplier tube. The modulated reference signal also enters the synchronous detector through a phase shifter. The signal is then allowed to pass through a low-pass RC filter. It removes the sum frequencies and a DC difference signal is amplified by a DC amplifier and then goes out to the readout. Readout devices. Chart recorders or digital readout devices are used in atomic absorption spectroscopy. A chart recorder is a potentiometer using a servometer to move the recording pen. The pen displacement is directly proportional to the input voltage.